this is Algebra 1, Lesson 82. We're going to be evaluating functions and talking about domain and range. We're starting on page 337 in your book. We learned about functional notation in Lesson 28. Remember, we read this as f of x as the function of x, or f of x. The expression has one solution for every value of x. So if f of x equals x squared plus 5, if we have f of 1, that means we substitute 1 into every x. So this would be 1 squared plus 5, which equals 1 plus 5, which equals 6. If x equals negative 1, so the function of negative 1 is going to be negative 1 squared plus 5, which equals 1 plus 5, which equals 6. If the x equals 2, then we have 2 squared plus 5, which equals 4 plus 5, which equals 9. If the x equals the square root of 2, then we have the square root of 2 squared plus 5, which equals 2 plus 5, which equals 7. Right? So let's try another one here. If the f of x equals x squared plus x minus 10, then find the function of 5. Okay? So that means we're going to substitute for x, for every x, we're going to substitute 5. So this will be 5 squared plus 5 minus 10, which equals 25. 5 minus 10 is minus 5, which equals 20. So the f of 5 equals 20. Okay? If the h of x, it does not have to be an f, if the h of x equals x squared plus x plus 1, find the h of a squared. It does not have to be a numeric number in here. It can also be an abstract equation like this. So for every x, we're going to substitute an a squared. So this is a squared squared plus a squared plus 1. This is a to the 4th plus a squared plus 1. And that would be your answer. Okay? If the f of x equals x squared plus 1, find the f of x plus 2. So for every x, we're going to substitute x plus 2. So we have x plus 2 squared plus 1. Okay, x plus 2 squared is the same as multiplying this plus 1. Okay, so we're going to do FOIL. This is x squared plus 2x plus 2x plus 4 plus 1. Don't lose that plus 1. So now we have x squared plus 4x plus 5. And that would be your answer. Okay, when we have a function like the f of x, or the function of x equals 2x, the set of acceptable x values, or we can call it the set of inputs, the numbers that we are going to put into this x, this is called the domain. So any acceptable number we can put into here is called the domain. The set of acceptable solutions or outputs, I should actually have made this arrow go this way. The set of acceptable solutions or outputs is called the range of f. So this is the range of f, and this is the domain of f. We say an x value or a solution is acceptable if the value that we either put in or get out does not require us to take the square root of a negative number or divide by 0. We need real numbers for these, so we can't end up with the square root of -3, because that's an imaginary number. We also can't end up with 2 over 0, because that's undefined. We can't have 0 in the denominator. So any real number that does not leave us with a 0 in the denominator or a square root of a negative is acceptable. So let's try some examples so you can see how this works. If the f of x equals 2x, find the domain and range of the function f. Okay, so the function can be applied to any real value of x, because no real value of x here is going to make this a square root of a negative, or it's going to make this with a 0 in the denominator. Okay, because the denominator is already 1. The variable is here, so nothing we are going to put in here is going to make this have a 0 in the denominator. And we can't put a real number in here and get an imaginary number here. So our domain, the domain of f, is going to be the set of all real numbers. Because you can put in any real number here and get an acceptable answer here. Okay? So the domain of f in this case is all real numbers. The range of f, in this case, if we put any real number in here, we're going to get a real number here. Okay? So the range of f is also going to be all real numbers. If we graphed this line, when we graph functions, we treat f of x like the y, and then the 2x is the rest of the equation. So if we graphed this, we would get this line right here. The slope is 2, right? The y-intercept is 0, and so we get this line here. Because this line goes on forever, that's another way of telling us that both the domain and the range, so for any value of x, we have a value of y. We have an infinite number of ordered pairs that will be a solution to this line. So that means any real number will be the range or the domain. Okay? Let's look at if f of x equals 3. Find the domain and range of the function. Okay, we can read this as for any real value of x, f of x equals 3. Right? So the domain is going to be, once again, because the domain is what values of x you can put in here to make this true. The domain is still going to be the set of real numbers. For anything you put in here, it's always going to be 3. Any x is not going to change this 3 because there are no variables on this side. Okay? So the domain of f equals, once again, the set of all real numbers. The range, the only answer we're going to get is 3. For any real number we put into here, the answer here is always going to be 3. So the range of f is, the only number in this set, is 3. And of course, if we graphed this, remember when we graphed this line, the f of x acts like the y. So this would be y equals 3, and we're going to get a horizontal line where y equals 3, and for any x, y equals 3. Right? So it's going to be a horizontal line. Okay, here's a crazy one. If the graph of a function f is as shown, and here's the graph, determine the domain and range of f. So we have this function. It's not a straight line, so neither the domain nor the range is going to be an infinite set. You see they both stop. This one stops here. This one stops with an open circle. So it's not actually going to equal that point, but it's going to come right up to it. So this is not an infinite line, and it's not a straight line. So we already know, just from looking at this, that neither our domain nor our range is going to be the infinite set of real numbers. So let's see what it is. The domain is a set of possible x values. We see there's an open circle here. This is at -2 and 3. So that point is not a solution for this. But all of the real numbers to that point from the origin are. So we can say that the domain is going to be greater than, but not equal to, -2, right? It's always going to be bigger than -2. So we can start by saying the domain of f, right, equals, and it's a set, it's always going to be bigger than, but not equal to, -2. We're talking about x. Okay, here's the other point, and this point is at 3 and 4. It has a closed dot, so this point is part of the equation that is graphed. And we can see that all of the real numbers between the origin and 3 are going to be included. So this is going to be x is less than or equal to 3. Okay? We're not quite done yet though. We need to define this set as being part of the set of real numbers, because those are the only ones that will be acceptable values of x in the function. So we're going to write that this way. Okay, so let's write this over here. The domain of f equals the set where x is in the subset of real numbers. Okay, it can't be an imaginary number, so it's in the subset of real numbers, such that, and when we say such that, we're just going to write a straight line. So, the domain of f is in the set where x is a subset of the real numbers, such that -2 is less than and not equal to x, and x is less than or equal to 3. Okay, that's ugly and complicated, but it's a complete thought or complete statement. So this is the correct way to write this. The range is for this is going to be the set of solutions for this graph. Remember that we said that when we graph a function, the f of x is the y. So the range of this graph is going to be all of the possible y values. If we look at this graph, the y is never negative. This is actually the graph of the absolute value of a y. So the equation to this is going to start with this, the absolute value of the y. So the range is going to have a lower limit of 0. See? And an upper limit of 4. That's as high as this ever gets. Okay, so when we talked about the domain, we said it couldn't be this point. Because x couldn't equal -2. But y can equal 3. It doesn't equal 3 here, but it does equal 3 at this point. So we don't have to leave that out. So the range is going to have a lower limit of 0 and an upper limit of 4 because that's as high as it gets. So the range of f equals, we're still talking about only real numbers where x is a real number. So the set of numbers where x is a subset of real numbers such that, and instead of dealing with x's now though, we're dealing with y's. So 0 is less than or greater than y, because these are the y functions, which is less than or greater than 4. Okay, so that would be your answer. Okay, let's try another one. Let's find the domain of the function f of x equals the square root of 5 minus x. Now we're only looking for the domain this time, so that's the numbers that we can plug into x to make this a true statement. Remember, the true statement that we come out of this with cannot be a negative number under the square root sign. So the x is always going to have to be 5 or less in this case. If it is greater than 5, then we're going to get a negative number here, and that would no longer be a real number. Okay? So the domain of f is going to equal, x is still a subset of real numbers such that x is going to have to be less than 5. So 5 is greater than or equal to x. It's okay if x equals 5, because then we have the square root of 0, and the square root of 0 is 0. It's okay if x is less than 0, if it's a negative number. If x is negative 2, then this is 5 minus negative 2, which is the square root of 7, and that's still a real number. Okay? So 5 is greater than or equal to 5. You could have also said x is less than or equal to 5. Okay? Okay, let's find another one. Find the domain of the function g of x equals 1 over x. Okay, in this case, we're going to be careful of having a 0 in the negative. A 0 in the denominator. So the domain of f is going to be the set where x is a subset of real numbers, and it can be a positive number. It can be positive, it can be negative, it can be any real number except 0. So we're just going to say x does not equal 0. Okay? This is a little tricky, but I think you can handle it. Try the practice problems, let me know if you have any questions, and then do your homework. All right? Thank you very much.